Lesson 14, determining the theoretical probability of an event. So when we have an event, there is, like flipping a coin or something like that, there's what's called the sample space. The sample space is just a set of all possible outcomes. Doesn't mean you're going to get every outcome, but it's just the set of all possible outcomes that you can get. So for example, if our event is flip a coin, the sample space is the set, so you have to have braces, heads and tails. So those are the two elements of the set in the sample space of flipping a coin. What about rolling a dice? If it is a six-sided cube, then our sample space in braces is 1, 2, 3, 4, 5, and 6. Those are the only numbers we can roll on a standard number cube. If we were going to flip a coin and then roll the dice, our sample space would be heads 1, because we could flip a heads and roll a 1. We could flip a heads and roll a 2, heads 3, heads 4, heads 5, heads 6. Then we can also flip tails with all those numbers. So tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. And your braces. Now a simple event is an event with only one outcome. So here's an example. Rolling a 5 on a number cube. There's only one way to get it. Another example would be flipping a coin and getting tails. Now, theoretical probability is what theoretically you should get. So I'll explain that in a second. So theoretical probability is a fraction, and it's the number of favorable outcomes. That means how many times can you expect it to happen in out of the total number of outcomes. So the number of total outcomes. So we're going to give the example of what's the probability of rolling a 5 on a number cube. Well, the number of 5s on the number cube is 1. So the number of favorable outcomes is 1. The total outcomes you can get when rolling a number cube is 6. So the probability of rolling a 5 is 1/6. The probability of flipping tails on a coin. So there's 1 tails on a coin, and there's 2 sides to the coin, heads and tails. So the probability of getting tails, theoretically, is 1/2. The complement of an event. The complement is basically the set of all outcomes not in a given event. So the complement of rolling a 5 on a number cube is the probability of not 5. So every other number but 5, and there's 5 of those, and there's 6 total numbers that you could roll. always, if you take the probability of the event and add it to its complement, which is the probability of not that event, you should get 1. So if you notice, rolling a 5, we got 1/6. Rolling not a 5, we got 5/6. If you add those together, you'll get 6/6 or 1. There's one more vocab word, and it's chance. It's the likelihood, and that's it's also a probability of an event occurring. It's written as a percent. I always think of the weatherman. He says, what's the chance of rain? And he'll give it as a percent. For instance, 40% chance of rain. So I'll just put in here chance of rain. And we're going to do a little experiment in class where we are going to make a table. We're going to have the colors. We're going to have tiles in a bag, 4 different colors. We're going to tally how many we have when we draw them out of the bag and the frequency that they occur. And then we're going to talk a little bit about more about theoretical probability and then actually what we got, which is would be considered what's that considered? Experimental probability. Okay, that's the end of the lesson.